Good afternoon. Welcome to this session on From RAG to Enterprise AI Agents, Building Intelligent Java Apps. My name is Mark Heckler.
I'm Asa Singh. Microsoft started Java in 1995, being 30 years strong.
Yeah,
How about you?
Sometime around the same time. We were just talking about that and how exciting and depressing that is all at the same time. So let's get started quickly and jump right into it. We have a lot to cover, and we'll try to do all that we can as quickly as we can without pinning you to the back wall here. So let's start by understanding the key components of a pattern for AI-powered enterprise applications. First, Retrieval-Augmented Generation helps in generating real-time context-aware responses. Embeddings and vector databases are used for efficient semantic search and knowledge retrieval. Function calling allows the system to interact with enterprise APIs, fetch real-time data, and automate workflows. Agents are AI programs that automate and execute business processes working alongside or on behalf of a person, team, or organization. This pattern retrieves relevant real-time information and triggers actions dynamically, making applications smarter, more efficient, and more interactive. For enterprise-grade AI applications, it's important to consider aspects like security, compliance, observability, say that 3 times fast, structured outputs, and of course, reasoning. These fundamentals ensure that the AI system is reliable, trustworthy, and integrates seamlessly with other systems. Some key AI applications for Java developers include intelligent workflow automation, AI-augmented search and recommendations, AI-powered process and operation assistance, personalized customer support, and AI-driven decision support systems. These scenarios show how AI can streamline processes, improve efficiency, and provide tailored solutions, making your Java applications both smarter and more responsive. So imagine a production manager at an auto manufacturer such as Mercedes-Benz or Ford asking to optimize the assembly line schedule based on current component availability and order priorities. AI steps in by retrieving real-time inventory data, identifying supply constraints, and suggesting a dynamic production schedule to minimize delays. This reduces downtime by optimizing assembly workflows and improves overall production efficiency and order fulfillment. For Java developers, integrating such AI capabilities can lead to smarter, more efficient production systems.
AI-augmented search and recommendations. They automate complex logistics, supply chain, and inventory processes by retrieving real-time data and executing business function. For example, an appliance manufacturer, say KitchenAid or Bosch, you can think of them, right? And they want to optimize supplier selection for assembling household products. So a procurement manager is asking the AI to find the best supplier for high efficiency, and so that they can get the suppliers with shortest lead times and best compliance rating. So what the AI does, it scans the manufacturer's all kinds of databases, including procurement databases, evaluates supplier performance history, their lead times, their compliance rating, and recommends the best option. This way, it reduces the time taken and optimizes the delivery efficiency for the assembly line.
AI-powered process assistants enable the automation of complex logistics, supply chain, and inventory processes by retrieving real-time data and executing business functions. For example, imagine FedEx or UPS or DHL using AI to optimize delivery routes in real time. A logistics manager might ask, what is the fastest rerouting option for delayed packages due to weather? AI retrieves live weather reports, current traffic data, and delivery schedules, and then suggests an optimal route and triggers a notification to drivers. This reduces delays and optimizes delivery efficiency while enhancing customer satisfaction with more accurate ETAs.
AI-powered operation assistance, right, which enhances various operations by retrieving relevant data and triggering automated workflows. For example, there are many wealth management companies, right? Imagine Fidelity Investments or Morgan Stanley. What happens there is, in that example, AI can pull real-time data, market data, and retrieve historical risk assessments. This allows the financial analyst to quickly summarize the risk exposure of their portfolio given what is happening in the market today. So the business impact here is really profound. Faster and more accurate risk analysis, which leads to better decision making, while real-time information reduces the operational risk.
Another scenario is personalized customer support, where AI enhances customer service by retrieving relevant information, automating responses, and executing system actions. For example, airlines like American, United, or Delta using AI to handle customer inquiries more efficiently. A passenger might ask, "My flight is delayed. Can you rebook me on the next available one?" Not an unusual request. AI retrieves real-time flight schedules, identifies available booking options, and automatically updates the booking based on passenger preferences. This reduces manual intervention for customer service agents and enhances customer service with fast and personalized responses, leading to higher customer satisfaction. At least one would hope.
Yeah. So AI-driven decision support system, right? This enhances decision making by analyzing business trends, generating reports, and providing insights. Imagine, for example, imagine financial institutions like Northwest, BNY Mellon, or JP Morgan Chase, right? Where they use AI to speed up the financial analysis and investment decisions. AI retrieves real-time market data, analyzes historical trends, and generates structured reports. This provides data-backed insights for portfolio management, enabling faster and more accurate decision making. Here again, the business impact is profound. It reduces the time taken for financial analysis and enhances the quality of decisions, ultimately better portfolio performance.
So now that we've explored 6 representative scenarios, let's zoom in on RAG, or Retrieval-Augmented Generation. RAG is a powerful pattern that retrieves relevant, real-time information and triggers actions dynamically, making applications smarter, more efficient, and more interactive. Imagine a system that can understand the context of a query, fetch the most pertinent data from vast databases, and generate accurate, context-aware responses instantly. This is the essence of RAG. By leveraging advanced AI techniques, RAG enhances the capabilities of applications, enabling them to provide real-time insights, automate complex workflows, and deliver personalized experiences. Whether it's optimizing delivery routes, automating risk analysis, or enhancing customer support, RAG plays a crucial role in transforming how businesses operate, making them more agile and responsive to ever-changing demands.
So now to bring everything together to life, right? We need to use data, app, and AI services. This, we call it as the AI app platform. This platform is designed to help developers deliver on the promise of building amazing intelligent apps. It's an integrated platform that encompasses developer services, application services, databases, and AI services. Now, each element supports what you already use, right? You already know many of these things on the board to help you make your apps intelligent. So the stack also integrates the AI services on the right. So let's look at some of the pieces in this diagram, because we are going to drill today into each of these boxes. So the developer services, these are the tools and frameworks that devs use to build apps. They include everything from coding environment to testing tools. The container services, the platform services, this is where your apps are running. It provides the infra and services need to deploy, manage, and scale your applications. Now the data platform, this is where your data lives. It includes databases, data lakes, other storage solutions that help you manage and play with the data. Now AI platform, that's the last one here. This is where the magic happens. It includes AI models, machine learning tools, and other AI services that help you build the intelligent apps. Now, by integrating these, we create a platform. You have a platform that helps you build, deploy, and manage apps, intelligent apps efficiently.
So we just discussed the integrated AI application platform. So let's now dive into the specific tech stacks for app types like Spring Boot and Quarkus. For Spring Boot, the tech stack includes things like the app hosting service. For the AI library, say that 3 times quickly, we're using Spring AI. We're using OpenAI for our LLM, for our intelligence, if you will, our AI. And of course, for business data, we're using Postgres, and for the vector database, Postgres with pgvector. For Quarkus, the tech stack is very similar, right? The only, I guess, significant change that you would envision in this type of a thing is using LangChain for J instead of Spring AI. The tech stacks are designed, again, to be very similar, but also to leverage the fundamentals we discussed earlier, such as keyless authentication, observability, and debugging. However, let's relate this back to the numbers from the previous diagram. Number 2 refers to the app platform, which provides the infrastructure and services needed to deploy, manage, and scale your applications. Number 3 points to the data platform, which includes databases, data lakes, and other storage solutions to help you manage and analyze your data. Number 4 highlights the AI platform, which includes AI models, machine learning tools, and other AI services that help you build intelligent applications. In the bottom half of the slide, we have the RAG pattern outlined in boxes. Now, this pattern is crucial for understanding how responsibilities are divided among teams. The top row is designated for AI engineers and data machine learning engineers who focus on tasks like business data processing, chunking, embedding models into vector databases like Postgres or Cosmos, and querying those databases efficiently using prompt and context mechanisms leading up to LLM and AI responses. The bottom row specifically is designated for developers. Most developers, honestly, including Java developers who work on integrating these components into real-world existing or new applications, ensuring seamless functionality across different layers of our tech stack. By breaking down these roles clearly within the RAG pattern framework, we ensure that everyone understands their responsibilities, making collaboration more efficient across teams. This integrated approach helps developers and customers deliver on the promise of intelligent applications, leveraging the app platform, data platform, and AI platform to create smarter, more efficient solutions in whole. So let's build an intelligent Java app with AI using Spring Boot, mostly from scratch. So time is rather limited, so I'm going to take a couple of shortcuts, but I'm going to walk you through it as I go, and hopefully everything will work. Demos never fail live, right? Never, ever. Yeah, yeah. Oh, demo gods. Okay, so let's, you can do it.
There it is.
All right, okay, so everyone can see that, right? That's not just me? Yeah. All right, good. All right, so the first thing I'm going to do is, let's see, I'm going to go over here and just, well, the first thing I'm going to do is close that out because no spoilers. So I'm going to go to the start. Excuse me, can't even talk now. English hard. So the Spring Initializer is the place where you go to create new Spring Boot applications, and you can do that from start.spring.io in the browser, or you can just curl it. It's the same place, right? You're using the API versus the browser interface. But I'm just going to use this because it's faster in this case, just to go ahead and drop it out there. I'm then going to unzip our file, -d Spring AI app, and we'll drop that in there, and then cd into that, and then, yep, looks good. I'm just going to open that in code and expand that, and then close this lovely welcome screen out. That's good. I'm going to open my POM file for two reasons. One, because trust but verify is a real thing. I like to make sure that everything looks like it's properly positioned. Everything is. All looks good. We'll enable null annotation types. That's good. And then I'm going to go back and grab an additional dependency here that isn't in the Spring Initializer, but is very important for our purposes nonetheless. And I'm just going to drop that in there. Did I drop that in there? No, come on. Oh dear. Well, okay, let me go back, grab, tab, drop. That's happier. Let's format, save, and yes, please keep that up to date for us. Wonderful. Okay, the next thing I like to do is, well, before I go too much further, let me explain kind of what these are, the dependencies. So we have a Spring Cloud Azure starter, which gets us the goodies for Spring Cloud Azure, integration with things like our service registry and our configuration server, config server. Then we have an Azure OpenAI Spring Boot Starter, which allows us to integrate easily with OpenAI models and the API running on Azure. PG Vector, which gives us our vector store capabilities in Postgres. And then, of course, we have our JDBC starter for Postgres. And that's all the key bits, anyway. The next thing I want to do is just open up our application.properties because I'm going to add a bit more information in there. And I'm going to grab that and paste that in. And all I'm doing here is just pointing to our API key and endpoint, providing us a little bit of specificity in terms of the models we're using. Some of this is default, but I like to show it because it gives you a little more insight into exactly what I'm doing. And then, of course, we have our URL to access Postgres in the cloud, right? And then, let me go ahead and open up our main application class. This is what the Spring Initializer will create for you, is just that starting point. Any Spring developers in here? Okay, so you're familiar with this. Those of you who aren't, it's a great start. The application will run just like this. It won't really do anything, but it gets you started fast, right? So the next thing I'm going to do is just create a couple of classes. So I'm going to create my RAG service class. Service. Computer is so literal. Okay, so we'll just go here, and I'm going to copy paste this code in. And now let's take a very quick look at what this is. So I create a logger, no surprise there really. And I want to inject the auto-configured chat client builder and then just create a chat client directly from that. Inject our vector store, which is, again, auto-configuration steps in and does a lot of this for us based on our class path, including a dependency for our vector store and a few parameters that you saw in the application.properties file. And then really the key for everything going forward is this method, the process query method. And we provide a little bit of guidance in terms of how the vector store will do its similarity search. And then that's pretty much it. We provide some prompt text that we can embed our queries into, and then we're off to the races, right? But now that we have that, what I want to do next is create a way to get to that, right? So I'm going to create our RAG controller class. Oh, I just skipped ahead again. Let's see, let's do that again. Class, RAG, controller. I see in my mind where I want to go, and sometimes I tend to wish the computer could let me skip steps, but again, so literal. So not so with LLMs, right? Can anyone say non-determinism and keep a straight face? All right. So this is the controller class, and again, this is a very simple, streamlined example, intentionally so. I've created a single endpoint, which allows us to process a query, and then it calls the RAG service to pass along that query so it can provide the results of it. Again, very simple, very, hopefully, somewhat elegant. So I'm going to go out here and we'll do a maven w spring boot run. And we'll see if I missed any bits. Again, that never happens in a live demo, but just in case, you know, never hurts to check. So everything seems to be starting fine. Drat, fewer learning opportunities here. Okay, so that's up and running. So everything's connected, it appears. So the first thing I'm going to do is just hit that, HTTP, fingers in the right positions, please. And we'll just ask, what is PG vector? Pretty simple question, right? We'll see if we can get back a meaningful response. Good, there's no red on that other screen, so that's a good sign.
Worked.
All right, yeah, it works. Whew. Oh my goodness, yes. Okay, so we're still connected. Demo got still appeased. So that's pretty good. Let's go ahead and do another query here, another prompt. So we'll just ask, how does question answer advisor work in Spring AI? And that may have to think on that. I say think. It may have to compute on that a little bit here for a moment. So while that does that, oh, well, never mind. We've got a really good connection here.
Yeah,
that's great.
Pretty fast.
So this is pretty good, right? It gives us some basic information in terms of how question answer advisor works. Now, we can, in theory, kick this up a notch. It's always fun to do. So I'm going to add a document service that lets us add a bit more information, a couple of documents, if you will, to our vector store. So we'll create our document service. I'll go over and grab that as well, because that's a lot of typing, and it's just like text, so nobody really wants to watch me type all that text. But what this is doing is just creating a couple documents and pushing them to our vector store, right? So we'll go out here, and I will stop that and restart that. And then we'll query it again, and now it has a little bit more information. I didn't go crazy with the documents, so it's not going to change things much, but it should give us a little higher fidelity information. So we're.
Does vector store come from?
Pardon?
Which dependency does the vector store come from?
Oh, boy, I'm glad you said that, because I just realized that I kind of blithely skipped over something else here. So if you go here, so our vector store actually is this. And actually, a couple, but the key bit is right here, the Spring AI PG Vector Store, Spring Boot Starter, and then of course PG Vector is an extension to Postgres. So we have our Postgres JDBC and
They have
API
pluggable
as well.
dependencies. You can put whatever vector store you like.
So I did want to mention, and this is the other reason I was glad you asked that, because I failed to mention that obviously we're using Azure OpenAI, we're using PG Vector running, or Postgres running somewhere. We're accessing all of this stuff. I went ahead and pre-created all that because that takes a significant amount of time, and they tell us we only have 3 hours here. So I'm trying to, okay, 45 minutes. Nobody panicked and ran for the door. That's a good sign. So yeah, all right. So we're up and running. Just let me run this again, and we'll see. So this, again, I only gave it a couple small documents, so it doesn't dramatically change, but you can see some significant details in there, a little more context, and of course, the more data you give it, the more you get back, garbage in, garbage out, but the more information it has that's in your vector store, the better the similarity search results will be, as with all things AI, I guess. So with that, let me turn it back over to Aser, and he'll take you on to the next level.
Because you said you prepared something beforehand, so you prepared and fed some documents into this.
No, he just added 2 documents
Just 2
live.
more,
So
yeah,
it was
they were-
empty.
It was empty and
Correct.
2 documents.
Right.
Yes.
So at the risk of, if anybody isn't exactly aware of how this typically happens, if you do a RAG search and there's nothing that's directly relevant, you're not really adding anything of value to the query to the LLM, the prompt. However, if it finds something relevant in the vector store, then it helps guide and inform the LLM's response, so you get a higher fidelity response. Potentially, hopefully.
Is it already pre-trained when you put in the dependencies, or what is it like?
No, you can either, well, what I like to do is give it some documents, place some documents in there. But I mean, there's nothing saying you can't start with an empty vector store and then add it as you go along. Because, I mean, think about normal enterprise usage. You're going to be creating new, I say documents, but new sources of information, new sources of valuable data almost on a daily basis. So you'll start by filling in as much as you can typically to get the best responses you can, knowing that that's going to be a never-ending cycle. Every day or week or month, you're going to be adding potentially new informative data to that for better results as time goes on.
I think that question is a good one to summarize this tag, right? The one you put it here.
One more quick
One more
question, then we
question?
need to roll on.
The defaults for chunking and embedding.
We use the defaults for this demo,
Yeah.
but there should be a lot more configurations for you, right? You can
Yeah.
enjoy all those.
I was
menus.
going to say, I always stick with the defaults as long as you get satisfactory or
Correct.
even superlative performance out of it. Otherwise, then I start tweaking. Typically with Spring AI, they go to a lot of trouble with Spring engineers to determine what is the most appropriate sensible defaults. So I always start there, and if performance and results are adequate or again, very good, I don't look to optimize that and do premature optimization, only if need be. So I try to adhere to the defaults as much as possible. Even some of the things that I add in my application.properties, like the text embedding model and the chat model, those are defaults based on the Spring AI property settings. I just showed them because that way there's not a question which model are you using, because I wanted to call it out a little bit. But those couple that I listed are the defaults. So
Okay.
yes,
Wanna
carry on.
summarize?
Oh, yes.
Yeah.
So just to summarize what we just built and kind of pull together. So we started by creating a Spring Boot starter project that included Spring Web for the API, JDBC for data integration or connection, Spring AI, OpenAI integration, and a vector store using Postgres with keyless authentication, to Postgres for security purposes, to keep things as tight as we can. Next, we added both a RAG service and a RAG controller to manage the Retrieval-Augmented Generation. And our integration efforts focused on connecting OpenAI's models with our Postgres vector store to handle embeddings effectively. To facilitate interaction between the client code and the backend services, we use Spring AI's capabilities extensively. After setting up the components, we conducted some initial tests on our intelligent apps, which provided reasonable results, right? But then to enhance the accuracy further, we populated our vector store with a little bit more knowledge. Again, it wasn't anything to shout about, it was just something to help guide the conversation a bit. And with real world data and volumes of it, that becomes much, much, much more noticeable. So the entire setup was accomplished pretty quickly, right? I did copy paste, but as you can see, especially with the controller, it's very minimal code that you need to do to expose an API that you can actually start using the LLM and accessing your vector store pretty quickly and easily, and then scale out from there. It's a pretty simple affair, really.
Okay, so now that we explored the capabilities of the RAG, let's step up a notch into the realm of AI agents here, right? So an AI agent is a software entity. It's designed to perform tasks autonomously or semi-autonomously. It receives some input, processes that information, and takes action to achieve specific goals. Remember all the scenarios that we talked about? Unlike RAG, it focuses on generating, unlike RAG, which is actually focusing on generating context-aware responses, AI agents can make decisions and execute tasks independently, enhancing the automation and efficiency in all the scenarios that we talked about.
AI agents offer modular components which make it easy to define tasks like data scraping or API interactions. They work together to handle data collection, analysis, and decision making, forming a smart system. These agents also collaborate with us humans, right? Assisting in decision making while humans refine the outputs. They streamline operations by automating workflows across various systems and tools. AI agents are scalable, distributing workloads across multiple agents, and they're autonomous, learning from data to improve over time. They connect seamlessly with APIs, databases, and cloud services, and they respond to events in real time, optimizing both automation and security. So here are some fundamental privileges of AI agents. These include the chain workflow, which breaks down complex tasks into manageable steps. The parallelization workflow, say that 3 times fast, where AI models work on tasks simultaneously and combine their outputs. The routing pattern distributes tasks to the right agents, while orchestrator workers manage more complex behaviors. Lastly, the evaluator optimizer involves one AI model generating responses and another evaluating and refining them, which is really fun, right? Really cool. These patterns help optimize AI performance and efficiency, making them essential for advanced AI workflows.
So what we're going to do is we're going to pick up on the last primitive Mark explained, evaluator, optimizer, the dual model, right? So we're going to work on a demo here. So let's explore that demo a bit. So it's a blog writing agent demo. It's a tool that uses the evaluator optimizer pattern to enhance content automatically. It refines content through multiple iterations to improve accuracy and the quality. So it works in 3 important steps, simple steps. There's a generation of the AI draft of the blog post, and then there's an evaluator. So the evaluator is going to evaluate and give some feedback, and then the refined steps where the editor keeps picking it up and refining it, right? Think of it like you're writing a blog and you're the editor, and then you're the writer, and then the editor is reviewing and giving you feedback, right? So this is a dual agent workflow involving a writer who's generating content and an editor who's evaluating the content, ensures that the content is not only generated, but also refined to perfection. By using this pattern, it can automate the content improvement process, make it more effective and efficient. So you're going to see how we are going to use agent and AI right away. So let's go straight into the demo. So this is where I have to stop mirroring, right, and quickly say I want to mirror it. All right, so, and then I open this guy, start with, so it's the same program that Mark was actually playing with. And I've added a bunch of classes here. I want to start with, I just added a controller to pull the blog out, right? It's an API. And then I want to show you this writer service. So this is where I'll show you some key elements and I'll come back and explain a little better, right? So this is where I have the writer agent, where I'm building a prompt. You're a professional writer and you write well-structured, engaging blog. They should have a clear intro, body paragraphs, and conclusion. And I'm also giving him, it should be a little bit professional and conversational. And these are some formatting requirements. You format it in this way. There should be a title, caps, separating blank lines, all those stuff, right? So it's like elements of style. So this is where the first call goes through, right? This is where it reaches the AI and AI generates here, right? And then when the generation happens, then it goes to the evaluation loop right here. So this is the loop. So the first round we are asking, okay, evaluator, it's the next agent. What you're going to do is you're the critical blog evaluator. You are going to evaluate this, and there are some rubrics to evaluate that. So these are the rubrics, and it's important that the size is important, the count, right? And all of those feedback is given. So the evaluation comes out, and the evaluation comes out as either it passed the evaluation or needs improvement. And if it gives needs improvement, it comes back with information as to how to improve. So that is called right here, right? So when that happens, and it goes through the loop, and then it goes through, in case it didn't meet the requirement, then it goes back to the editor, the actual writer, the writer agent again. And now we are giving more instructions, right? Based on the feedback, how to process the feedback and rebuild that. And that comes through. And then it keeps going on in circle iterations until it is able to generate. And finally, if it's not approved, then there is a fallback. You can also come up with a fallback, right? So with this, let me show you how this actually goes through, right? So I've shown you all three agents. So I'm going to run now. I have it here. So I'm starting the run. One of my keys is in the chain, so it's asking me. So it is connecting right now, and it should be up and running. Cool. It is up and running. So while it's up. It's connecting. Okay. So let me construct a request at this point. So I have this request. Let me clear this first. So I have a local request. So I'm just going to send it, and it's going to start the process, right? So you can see this backend is running, right? So the first draft is created here. This is the first draft. You can see that it talks about the various pieces here being generated right here, right? And then it goes into the review. So once it goes through the review, it says it needs improvement somewhere here. So here is the first draft. I think this is the second draft, right? It went through the thing. It talks about how Java has been a cornerstone for enterprise apps. Whether you're running Spring Boot or any other service, you can deploy on many services like App Service. And in conclusion, Java on Azure provides the best blend of familiarity and innovation. And you can see that it came back as needs improvement right here. And the criteria and the evaluation content is right here in a structured format. And then it goes through the loop again, and it's again comes as needs improvement. And this time, it explains very clearly in iteration 1 what are all the changes that need to be done, right? And similarly, then the next round draft is prepared. You can see that it's tightening. And I think the best way to read is the last sentence, how it has improved. In conclusion, Java on Azure provides the perfect blend of familiarity and innovation, empowering devs to build and scale implicit applications with confidence, right? So this has changed a bit. So it goes through another round of reviews, and it comes back as needs improvement, looks like, and yeah, it says needs improvement. So that's the second run, and it goes through the process, and it gives you all the feedback, and it goes through the process again, and now it is. You can see the conclusion sentence has changed. Many things have changed, but let's look at the conclusion. Azure's robust support equips developers to innovate confidently. So it's now talking about the future, right? And it goes through, and this round it may pass. Maybe it passes. Oh, it's about to. It still needs improvement. So it goes through another cycle, and finally, I think, let's go to the bottom. It has done through 3 iterations to get the blog approved, and the approved blog is right here, right? So you saw how we gone through 3 of the iterations here. So I'm going to go here, back to my IntelliJ. I'm going to add a Docker file, very simple Docker file. It's a 2-stage. I'm building it here. I think now everybody should be familiar with Docker file, right? So, and here I'm just packaging it. So I'm going to deploy this to the cloud. So I have it ready here. That's a command. I'm just going to start it. It will start running, and in a few minutes, it'll be up in the cloud, right? Now, while this is running, just for the sake of time, what I did is I already ran once, and it's already up. So I'm going to show you that window now, okay? So it should be in my here, right? This is it, right? So I ran it, and you can see the iterations it went through in the cloud at this point. The address is right here. This is the URL in the cloud. And I've deployed to Azure Container Apps, which is the easiest to just deploy and run. So you can see that it went through 3 iterations right there. Okay. I think I want to come back to, while it's running, I do want to quickly show one small piece about the code as well. So you saw all the logging coming through amazingly well, right? So I just want to show you that piece. When we initialized in the Spring AI, they have this concept of simple logger advisor. It automatically logs all interactions. This is good for you, where you can debug. It's also good for your company, but the company also wants to keep track of what are the decisions that were made, what's the iterations, so that in the future, if they want audit. So there are many, all these building blocks in these frameworks like Spring AI and LangChain4j that you can use and take advantage of that. Okay? So with that, let me start shifting to changing the display to stop mirroring and go back to our deck. Okay. All right. So everything you saw here today, it's well documented. It's in one place, right? So if you want, you can take a picture of that. You see that URL downstairs. You can redo exactly what Mark and I actually did it today. Okay, so that's a very important piece here, right? So you can take advantage. So what we have developed in that example demo that we showed you, it's a dual agent workflow that involves a writer and an editor. The workflow is designed to streamline the content creation process. There's a phase 1. I'm going to go faster because of the available time. The phase 1 is a writer agent, right? You saw, and the phase 2 is the evaluator agent, right? And we constructed this workflow using Java and Spring. And it was very quick, and we deployed to Azure Container Apps. You can continue to manage this app as you move forward. So both Mark and I are going to go a little faster to cover.
Yeah, I'm gonna summarize this in just a couple of seconds here. ACA, Azure Container Apps, great place for your applications, your Java applications. It's a natural fit. It absorbs and uses various different container registries and OCI images to deploy and profit.
Yeah.
Short, sweet, and to the point.
Yes.
Yeah. So, again,
Okay.
you have access to all the different services available to Azure through Azure Container Apps.
Yeah. So let's come back and zoom out of what we just did, right? So there are many more relevant services for Java developers, making Azure a great destination. So for simplicity, what we have done is we have listed a few services here. So you are looking at the Azure AI platform. So you can imagine the developer services. You can imagine the container apps, Azure Kubernetes Service, App Service. These are the application services. And you can also see the platform as a service, app services there. For data, you have all the options like SQL database, Cosmos DB. We use PostgreSQL today for the demo. You can also, for the developer side, you can use IntelliJ, Gradle, Maven. He was using VS Code, I was using IntelliJ just to show you, right? And on the AI platform is where all the models are there, whether it's GPT-3 or 4, all of those things are right there, right? Now, you're going to tell me that, okay, Asir, we understand these services, but you have apps built using Spring Boot, Tomcat, JBoss, WebLogic, WebSphere. How do you go from there to the service, right? So this is a good map for you, right? It helps you navigate from your app type view. So if you're starting from a specific app, you can go column-wise, start traveling from the north to south, right? And based on your deployment type and your app type, from like whether it's a monolith or microservice, you can travel from the x-axis from left to right? So if you're deploying, I'll walk you through one quick example. If you're working with Spring Boot microservices, you can containerize them and deploy to ACA. If you're deploying a monolith jar, deploy to app service. So deploying monolith jar or AR is app service. If you're deploying as microservice or containers, you have ACA or Azure Kubernetes service. And for legacy, if your apps are inseparable from your app service, you can just deploy them to virtual machines. JBoss recommends if you're packaging as a container, deploy to Azure Red Hat OpenShift. If you're deploying just your ER, which are WAR packages, you can deploy to app service. So this diagram gives you very powerful view. Shall we go jump into that other?
You think we have time? Can we just do a quick summary? And
we can do a quick summary. So why don't we talk about this?
Yeah, so whether you're starting fresh or upgrading current solutions, integrating AI can help provide those smarter functionalities and improve performance and make your applications both more efficient and effective. While they're exciting, let me clue you in on something here. Just between you and us, we recently announced the private preview of a GitHub Copilot upgrade assistant for Java GitHub Universe. Mission critical tasks like upgrading and modernizing your code bases to reduce technical debt can be a challenge. Upgrading Java code, runtimes, frameworks, and dependencies can be time-consuming, but with GitHub Copilot's Upgrade Assistant feature, you can streamline the process significantly. Start with your local Java project, receive an AI-powered upgrade strategy, and let Copilot handle the bulk of the work. It really helps a lot. So I'm not going to read this for you, but we've all been there. Anybody who's had to upgrade a Java application knows that there are sufficient headaches to last for a long, long, long time and have the scars to prove it. So yeah, why do we want to upgrade them? A lot of reasons. There are many challenges. We've probably experienced them all, and if you haven't, you will, unless you try things like the GitHub Copilot Upgrade Assistant. Nobody likes pain, especially unnecessary pain, so use the tools at your disposal.
So the way the GitHub Copilot works, it comes in and helps you simplify these kind of open-ended tasks. It helps you with task planning by breaking it down, upgrade process into manageable steps. It uses behind the scene prompt engineering and logic to automate repetitive tasks. It uses tools like Maven, Open Rewrite to identify and resolve compatibility challenges. It takes care of error handling. It brings you also into the loop to apply whatever changes you like to apply. We have a 5-minute demo we can show you, but I'm also rapidly running out of time. So what we'll do is we'll do the closing and then start the demo. If you'd like to stay back and watch that powerful demo of moving from Java 8 to Java 21 like this, you can watch, right? Okay, with that, let's close this and then we'll come back to the demo. It is also available as private preview now. It's fully agent-driven. It helps you with that. So there's more, so you can stay tuned. But if you'd like to join us for the wait list, you can scan that and put your name in it, right? Of course.
Anyone can start today. So begin framing your app migration plans with resources to guide you through each step. Get started here in the first one with Start Java. Explore the docs and deploy your first Java or Spring app in the cloud, following the quick steps listed under the second QR code, if you will. Following that, use our tools and information to build a plan and show your leaders the benefits of Java app modernization. Hopefully they understand that, but if not, scan the third one.
Right. So we talked a lot about intelligent apps. We also want to learn a lot from you, how you are thinking through, how your organization is thinking through. This will help us shape the products and the tools and the services that we build for you. So take your time. It'll only 3 or 4 minutes. Try to fill this up. Come to the booth and we'll demo this for you. Amazing. It's a 5-minute demo. It's very quick. Right? And
Thanks for coming.
You definitely want to see and take it home. Yeah. Thank you for coming. Yeah.